Ramanujan for G is now available on the Google Play Store. Try it out for free.
So in the permutations and the combinations, we'll see some more topics. Okay. Yeah, so we'll start with the important results. Okay, important results. Okay, about points. Let me write important results about points. So there are endpoints in a plane. Okay, in which let me write endpoints in a plane of which m less than equals to n are collinear. Okay, then we can say total number of different straight lines, total number of different straight lines obtained by joining endpoints is nc2 minus nc2 plus 1. Okay, next is total number of total num right total number of different triangles different triangles formed by joining these endpoints will be nc3 minus mc3. Okay, next is total number of diagonals in polygon, number of diagonals in polygon, so that will be nc2 minus n, that you can write n minus 3 divided by 2. Okay, and one more is there. If m parallel lines in a plane are intersected by a family of other unparallel lines, then the total number of parallelograms that will be formed will be mc2 into nc2, that you can write it as mn m minus 1 m minus 1 divided by 4. So again I'm repeating, if there are endpoints in a plane of which m less than n are collinear, then first is total number of different straight lines obtained by joining these endpoints is nc2 minus mc2 plus 1. Second is total number of different triangles formed by joining these endpoints is nc3 minus mc3. Next is number of diagonals in polygons of n side is nc2 minus n, that is n minus 3 by 2. Next is if m parallel lines in a plane are intersected by a family of n other parallel lines, then the total number of parallelograms formed is mc2 into nc2, that you can write mn m minus 1 n minus 1 divided by 4. Okay, so just make a note for this first, then we'll look at some questions. Let's look at one problem. There are 10 points in a plane, and 4 of them are collinear. Then the number of straight line joining any two of them is. Okay, so solving, straight line can be drawn joining 2 points, so there will be a 10c2. So joining the 10 points, right? So but 4 of them are collinear, so you should get only one line joining any two of these 4 points, right? So meaning 4 of them are collinear. So you need to write total number of lines, that will be 10c2 minus 4c2 plus of 1. So solving will get as 40. Okay. Next question. If 5 parallel straight lines are intersected by 4 parallel straight lines, then number of parallelograms formed is. Okay, so meaning 5 line 1, 2, 3, 4 and 5, these are cut by 4 parallel lines, 1, 2, 3, 4. Here you need to find the total number of parallelograms. Okay. Okay, so you need to write number of parallelograms. So we already seen the formula is mc2 into nc2, so that is 5c2 into 4c2. So solving you will get as 60. Okay. Okay. Next, we've covered all the topics. So we'll see solved examples now. First one is one question is given. There are 13 players of cricket. There are 13 players of cricket. Okay, let me speak the questions and we'll solve only here. Okay, there are 13 players of cricket, out of which four are bowlers. Okay, out of which four are bowlers, meaning remaining nines are batsmen. Okay, so in how many ways a team of 11 can be selected of them so as to include at least two bowlers? Okay, we need to include at least two bowlers out of four. So meaning, again I'm repeating questions one time. There are 13 players of cricket, out of which four are bowlers. In how many ways a team of 11 can be selected from them so as to include at least two bowlers? So a team of 11 may be selected in the following three ways, like two bowler, nine others. Second, three bowlers, eight others. Third one is four bowlers plus seven others. So there are four bowlers, nine others. So total number of selections will be 4C2 into 9C9 plus 4C3 plus 9C8 plus 4C4 into 9C7. So solving 6 plus 36 plus of 36. So that is 78 as the answer. Okay. Again, I am repeating. A team of 11 may be selected in the following three ways. First is two bowlers plus nine others, three bowlers, eight others, four bowlers, seven others. So there are four bowlers and nine others. So total number of selections will be 4C2 into 9C9 plus 4C3 plus 9C8 plus 4C4 into 9C7. So that will be solving 6 plus 36 plus 36. So 78 is the number of ways of team of 11 that can be selected from which at least two bowlers are there. Okay, so you can write down the short solution. There are lots of questions we are having. Okay, next question. There are 10 points in a plane of which no 3 points are collinear and 4 points are concyclic. So the number of different circles that can be drawn through at least 3 points of these points is. Okay, repeating once again. There are 10 points in a plane of which no 3 points are collinear and 4 points are concyclic. So the number of different circles that can be drawn through at least 3 points of these points is. Okay, so you can write number of circles. So that will be 10C3. Okay, because at least 3 points we are selecting, minus 4C3 for concyclic plus 1 using formula. So solving you will get this as 116 plus 717. Okay. So the number of circles is 10C3 minus 4C3 plus 1. So it will be 117. Okay. Next question. To fill up 12 vacancies, there are 25 candidates, of which 5 are from SC. If 3 of these vacancies are reserved for SC candidates, while the remaining are open to all, then the number of ways in which the selections can be made is. Okay. Repeating once again. To fill up 12 vacancies, there are 25 candidates, of which 5 are from SC. So if 3 of these vacancies are reserved for the SC candidates while the remaining are open to the all, then the number of ways in which the selections can be made. Okay. So first, 3 vacancies for SC candidate can be filled up from the 5 candidates will be 5C 3 ways. Then after remaining for the members 12 minus 3, that is 9 vacancies. So there will be 25 minus 3, that is 22 candidates, right? So these vacancies can be filled up in 22C9 ways, correct? So required number of ways is 5C3 into 22C9. So this is your number of ways in which the selections can be made. Okay, repeating once again, 3 vacancies of SC candidates can be filled up from the 5 candidates in 5C3 ways. Next, after this remaining 12 minus 3, 9 vacancies, so there will be 25 minus 3, 22 candidates. So these vacancies can be filled up in 22C9 ways. So number of ways will become 5C3 into 22C9. Next one. There are 6-digit numbers that can be made with the digit 1, 2, 3, and 4, and having exactly 2 pairs of digit is. Okay. Meaning the number of 6-digit numbers that can be made with the digits 1, 2, 3, 4, and having exactly 2 pairs of each digit. Okay. So meaning the number will have 2 pairs and 2 different digits. 2 pairs and 2 different digits. So number of selections will be 4C2 into 2C2, and for each selection number of arrangement number of arrangement will be 6 factorial by 2 factorial into 2 factorial. So the required number of these numbers, required number of numbers is 4c2 into 2c2 into 6 factorial by 2 factorial into 2 factorial. So solving this 2 and this 12, 24, 1056, so 1080. Okay, again repeating, question is saying the number of 6-digit numbers that can be made with the digits 1, 2, 3 and 4 and having exactly 2 pairs of digits is. So first the number will have 2 pairs and 2 different digits. So the number of selection is 4c2 into 4 2c2 for each selection. Then the number of arrangement will become 6 factorial divided by 2 factorial into 2 factorial. So the required numbers of numbers will become 4c2 into 2c2 into 6 factorial by 2 factorial into 2 factorial. So solving you will get 1080. Okay, next is, let's look at the last question. A bag contains 3 black, 4 white, 2 red balls. All the balls being different. The number of selections of at most 6 balls containing balls of all the colors is. Okay, repeating, a bag contains 3 black balls, 4 white balls, 2 red balls. All the balls being different, and the number of selections of at most 2 balls containing balls of the all color is. Okay, so you need to write required number of selections. So that will be 3c1 into 4c1 into 2c1, 6c3 plus 63 plus 62 plus 6c naught. So solving this 42 into 4 factorial. Okay, so you can, let me repeat again. A bag contains 3 black, 4 white, 2 red, and all the ball being different. So the number of selection of at most 6 ball containing balls of the all color is. Okay, meaning we need to take 6. So you need to select 6c3 plus 6c2 plus 6c naught with the 2c1 or with all colors, and 3c1 into 4c1 for the black and the white and 2c1 for the red ones. Okay, so solving 42 into 4 factorial. Okay, so with this we are going to wind up the lecture here. Thank you guys.